We'll start this compression member. Most probably some part of the compression member we have already covered in the mid semester. Still we'll go for a background. What exactly a compression member is, if you look at this, what is compression member? A structural member which is mainly carrying the compressive force is known as a compression member. For example, you can say column, which you can see already in the life, in our daily life. If you take an example of say tower, it is also a compression member. If you take an example of stanchions are basically is a shorter length of column, they are called stanchions. So these are also the compression members. You can see here some examples are given in this section, that is columns, okay, stanchion. And if you take this roof truss, then the strut component, mainly this is the components, okay, this is the roof truss, and then this is the main members and this is the vertical members. So these are the members which are basically the compression members. Okay, so in this section we are trying to design the compression members. For design of compression member, mainly what we need to know the compressive area, that is area of the section. Suppose we are designing a compression member here with an I section, say this is an I section which will be used as a compression member. So what we need, I need to know what is the area of the cross section of this I section. Now it depends how you are using. Generally, if I section will be provided in a vertical direction, so I need to what is the cross section of this member. And suppose you are constructing a strut, mainly the struts are made of angle section. So what we need to know what is the cross sectional area of the angle sections. Okay, so basically for the design purpose we have to know the question. Then what is the next thing? Next thing is the permissible compressive stress. Okay, I am not going in details. Those who have the code books or those who have attended the earlier classes, what you can see that I told you what is this permissible compressive stress, or how to find out the permissible compressive stress. For that, if you follow the code books IS 800 1984, they have used the guidelines given by Rankin. Okay, using the Rankin guidelines, what we can do, we can find out the compressive force. Okay, let us see how we can do that in this part. Wait, let me see. Sorry, there. Situation. Okay, so this is the Rankine equation that is given in IS code for finding out the permissible compressive stress, that is sigma SC. Sigma SC equal to, I am not deriving it, in briefly I am saying, it is 0.6 times a factor is used multiplied by FCC into Fy divided by FCC to the power n plus Fy to the power n and whole to the power 1 upon n. This is basically derived by Martin-Jenkins, and that has been adopted in this code book. Now what is the meaning of the symbols? Here sigma SC is the permissible stress in axial compression, and unit is generally taken as Newton per millimeter square or MPa. Okay, Fy we know already, yield stress of steel, unit is MPa. Then FCC is called the elastic critical stress in compression, and this is calculated using this equation, that is FCC is equal to phi square E divided by lambda square. Okay, now question is what is this E and lambda. Okay, before I go there, let us know what is the value of n. N is the factors. In this code book they have considered this value as a 1.4. okay, what is E? E is the modulus of elasticity of steel, and this value as per the code book's guidelines we can take as 2 into 10 to the power 5 MPa. Okay, now what is left? This left is a lambda. This lambda is called the slenderness ratio. Now question is, what is slenderness ratio? Slenderness ratio is defined as the ratio of effective length to the radius of gyration. Okay, that means what we can write, this lambda is equal to L, or you can say L effective, if you say this is the called as effective length, divided by radius of gyration. Now which radius of gyration we need? We need to take the minimum radius of gyration. Now question is, what is effective length and what is radius of gyration? Okay, so let us first see what is effective length. So to see the effective length, this is effective length is basically we need to find out that at what portion of the column is mainly creating the buckling. So it depends on the support. Suppose we have a column like that. Okay, so let us say this type of support is there, and in another case we have another column with this type of supports. Okay, now in this case if you apply load, and in this case also if you apply load, now what you can see in the both cases, in first cases what you see, this support is a rigid support, so even if you apply the load also, the column directly cannot start buckling from the end. From this point it will not buckle, rather than what will happen, it will go away little bit from the support, and after certain distance from the support it will start buckling. Similarly on the other side of the, since we are using the similar types of support, so it will not buckle from the end, rather than after a certain distance from where it will start buckling. So this will be the shape of the buckling. Now what is the effective length is this distance, that is from which location it will start buckling and which location it will stop buckling. So this distance is called as the effective length of the column. Similarly, if you take this type of support, in this case what happen, if you apply the load, the column cannot go up and down, but the column can rotate, since horizontal rotation is not blocked here. So horizontal it is not restrained, that means it can start buckling from here. Since this is support and support also we are providing like that means this part also can end buckling. So if you say that this is how the shape of the buckling is, that means its distance from here to here is the full length. So that means you can say that this type of supports are there, then the effective length will be the full length, that is L. Okay, like that, depending on the other type of support. Suppose if you take this type of support, in this type of support what happen, this type is side is fully blocked, but this side if you allow like that, so in this case again what you can see, the horizontal and vertical movements are blocked, but in this case horizontal movements are permitted, so it will buckle like that, okay, from here to here it will buckle. So in this case the effective length will be from which location, from this location till this location. Okay, so based on this guideline, experimentally it is done, and a table is given in the code books, from where directly we can take what will be the value of effective length. Okay, so for this type of support, the code book is given that this effective length will be 0.65 L. Okay, so what is the code book table given? Let us see directly from the note itself. Okay, if you look at this table, okay, so this is the type of support which I was just talking about, that both ends are fixed and the rotation are restrained horizontally as well as vertically. In such case the effective length will be 0.65 L. So we can say L is equal to 0. That means the end-to-end length is L, but the effective length will be from here to here. Okay, so if you see this is written effectively held in position and restrained against rotation at both ends. So position is also blocked as well as horizontal movement is also blocked. Okay, next come to the other slide, other type of support. So in this type of support, what we can see that vertical movements are blocked, but horizontal movements are permitted. So it will start bending from the end itself. So it is called effectively held in position at both ends, but not restrained against rotation. So rotation is permitted. So this type of support condition, we can take the effective length as the full length. Okay, now if you see, look at this here. In one side a rotation is blocked, but other side rotation is permitted. But both sides horizontal vertical movements are not permitted. So it is written like this: effectively held in position at both ends, but and restrained against rotation at one end. In such case, the effective length will be 0.8 L. Okay, similarly, other type of situations are there. Let's see in these conditions. In this condition, what happened? One end is fully blocked. That means horizontal movement as well as the vertical movements are fully blocked. But other side, if you see that it is restrained against rotation, so horizontal movement is not permitted but not held in position, so vertical movement is permitted. Okay, in such case the effective length is 1.2. So it is written effectively held in position and restrained against rotation at one end, and at the other end restrained against rotation but not held in position. Okay, so this is the fourth case. Like that, we have 2-3 more cases are there. This is another case. In this case, if simply I am saying effectively held in position at one end but not restrained against rotation. So in this case, in one end vertical movement is not permitted but horizontal movement is permitted, and at the other end restrained against rotation but not held in position. It is rotation is blocked but vertical movements are not blocked. So in this case it is 1.2. If you go to the next slides, this is also another type, seventh type. Effectively held in position and restrained against rotation at one end but not held in position nor restrained against rotation at the other end. So in this case also it is 2L. Okay, so this is the seventh type. Okay, so these are the 7 type of support conditions that we can give, and depending on that we need to take the effective length. Okay, once we know the effective length, then what we need to know? We need to find out the radius of gyration. Now how to find out the radius of gyration? Let us see that part. Okay, if it is there, let me check it out. Okay. So radius of gyration, we can simply find out like that. Radius of gyration is equal to root over moment of inertia divided by area of cross section. Okay, so in which direction you are finding out the radius of gyration? For that particular direction you have to find out the moment of inertia, and area of cross section of any particular section will be same. So suppose you are finding out radius of gyration about x-axis. So what you have to do, you find out the moment of inertia about x direction. Similarly, if you are interested to find out radius of gyration in y direction, so what you have to do, you have to find out the moment of inertia about y direction. So I y divided by. So this is how you can find out the radius of gyration, or any other direction you can find out, and then you check which one is the minimum. That will be the least radius of gyration. So take the least radius of gyration and take this so effective length, find out the ratio, that will give you the lambda, that is called slenderness ratio, maximum slenderness ratio, because since we are taking this as minimum, so the slenderness ratio will be maximum. We take that value and use this value to find out the what is called sigma SC, that is maximum permissible stress, using this equation. So this is one way we can find out the permissible stress, maximum permissible stress, or the allowable permissible stress. Other way of finding out this is that in code book, if you see the code book in table number 5.1, okay, that is given in clause number 5.5. On that code book, a guideline or a table is given to find out the sigma SC value. This table is given based on the values of lambda and the values of Fy. Okay, lambda is given in vertical column for defined lambda value, and defined Fy value is given here. It start from 240, then 250 like that. Since in IS 800 1984 it is recommended to use Fy 250 still, so we will concentrating only on that 250 Fy 250. So here defined lambda values are there. It starts from 10 and it is given up to a value of 250, and for defined Fy value, what is the value of sigma as it is given here. So you can directly refer to this table and you can find out the value of sigma. Suppose your lambda value is coming some kind of fraction or in between, let's say it is in between 10 20. So what you have to do, you have to do the interpolation. So this is how we can find out the value of sigma SC from the table. Okay, or you can use the equation that is given in the code book. Find out the sigma SC multiplied by the cross sectional area A. Cross sectional area of the section, that is nothing but the total compressive force or compressive load carrying capacity of that section. Okay, so this is how we can find out the load. Either if A is known to us and sigma S we can find out, the load carrying capacity, or suppose P is given to us, load is given to us and it is asked to design us, then we can choose which section is to be designed based on this cadence. So this is the basic cadence. Now one thing which I was supposed to tell you earlier, that how this section is failing. Okay, what are the defined modes that a column section may fail? Okay, so that we have to check. A column section may fail by 3 defined modes. They are called crushing, buckling and mixed mode of crushing and buckling. What is crushing? When a column is very short and more loads are coming on the structures, what you can see sometimes that column is crushed fully. Okay, suppose let us say this is a column with a very short height of this column is there and more loads are there. So what will happen, you will find sometimes even in case of earthquake or many cases you will find that the this part concretes are getting out from this and only you can see the skeleton, that is the still reinforcement you can see. So this type of failures we generally call as a crushing failure as a layman language. Then what is buckling failure? Buckling failure, when we have a long columns are there and if we apply more loads, then column will bend like that. Okay, so how it will bend, just a minute. So in this case what you will find that column, once you have a column and load is very high, so column will bend like this. This is called buckling. And when the column is not so long or not so short, then the combination may occur, that is you can say the mixed mode of crushing and buckling. Okay, now depending on the slenderness ratio, the column is divided into 3 classes. Okay, these are called short column, long column and intermediate column. How we can say a column is a short column? When the value of slenderness ratio is less than 60, we generally called it as a short column. Sorry, when this value is more than 100, we call it as a long column, that means it will fail by buckling. When the slenderness ratio is less than 60, we call it a short column, that means it will fail by crushing. And when the slenderness ratio is in between 60 to 100, it is called an intermediate column. So the chance that it will be failed by mixed mode of crushing and buckling together. Okay, so these are some basic information that we need to know before we go for any kind of design of a column section. One thing is that how the failures occurs, what are the different types of columns are there, and then the Rankins equation that is given by the IS code IS 884, by which you can find out the total load carrying capacity of a compression member, that is nothing but equal to permissible stress multiplied by the area of the cross section. Now how to calculate the permissible stress, that is given in the code book. Okay, we have to use that equation to find out the value of sigma, that is sigma is equal to 0.6 into FCC Fy divided by FCC plus FCC to the power n plus Fy to the power n whole to the power 1 upon n. Okay, so we need to remember this equation, though it is given in the code book, or otherwise you can directly use the code book's given table to find out the value of sigma s. Okay, Now once we calculate this value, then you have to check there are certain limits are there. Okay, some kind of Kudal guidelines are given. We have to check that whether those conditions are satisfying by the column section or not. Okay, one condition it was we have to check that the maximum slenderness ratio should not exceed the Kudal provision. Okay, what are those Kudal provision given? Let us see those things first. So once we calculate the slenderness ratio, then it should not exceed this permissible value given in the code book. Okay. Okay, so this is the codal provision that is given in clause number 3.7 of the code book. Okay, what is that? Number 1, a member carrying compressive loads resulting from dead load and imposed load, the maximum slenderness ratio is limited to 180. That means lambda cannot be more than 180. In general normal cases you can say when only the simple a dead load from the structure itself or whatever the load is applied or live load, whatever it may be, based on that whatever the slenderness ratio you are calculating, it should not exceed 180. Okay, so that is the first condition you have to check. Suppose our member is subjected to other kind of load, not only the compressive simple compressive load, then what is to be done? It is written, you see the next one, a member subjected to compression forces resulting from wind or earthquake forces, provided the deformation of such member does not adversely affect the stress in any part of the structure. In that case, the slenderness ratio is limited to 250. That means what, in simple language we can say that when the compression member is subjected to earthquake load or wind load, in that case the compression member should the slenderness ratio or SR, generally denoted as SR or lambda, should not exceed 250. Simple case it should not exceed 180. Okay, now sometimes we are using flange also. Okay, so compression flange, the flange section basically is a I section. So whenever we are using such type of members, that is called compression flange of a beam, in such cases this value should not exceed 350. Okay, so these are some simple guidelines given in the code book and that we need to follow for the design purpose. Okay, once you check that, then you check that the section is satisfying. Okay, not 350, it is 300, sorry. The compression flange of a beam, it should not exceed 300. Okay, now just looking on a column with a simple column information, we cannot say that whether it is a simply supported column or some kind of other type of support is given. So for that a simple guidelines are there. You may not find it in the code book. In some books it is available. What it is saying that when we are using a web member, whether it is a riveted or bolted girder, whatsoever it is, in that case simply you take the effective length as 0.7 L. Say your support condition is not given to you, in that case you can take it like that. Okay, so that is one condition. Number 2, when we have a cord member, you take the effective length as 0.78 L. Number 3, top floor end column of multi-story building, take 1 L. Central column or interior column of multi-story building, take 0.5 L. Any other column it is there, the limit is 1 to 0.5 L. Okay, so these are the simple guidelines for compression member, that is for this column only. Okay, so next type of compression member is basically called the angle strut. Okay, we will see for angle strut what are the guidelines given in the code book. Okay, so now we will see the angle strut. In angle strut there are two types of angle struts are possible. What is called single angle strut, another is called double angle strut. So in single angle strut, again the possibility is there, it may be either riveted connection or it may be welded connection. In riveted connection it may be a single angle, only single rivet may be there, or maybe two rivets may be there. Similar condition may occur in case of double angle strut. It may be with single rivet, or it may be with double rivet, or it may be with welded connections. Okay, Let us see one by one how the code book is given. If you refer this code book, clause number 5.5, and under that 5.5.1 section, it is given for single angle start. If you look at this, this is given for this single angle start. Okay, single angle discontinuous start. That means the end of the starts are up to this part. Okay, the angle is discontinued. After that, means what I mean to say that after the connection, it is not continued. Okay, so let us say this is a single angle discontinuous start. Means if you see the section, the section is like that. Okay, this is a single angle start. In case of single angle start, what is the guideline given in the code book? Let us see. So this is the angle start. Okay, so first you write down number 1. If you are noting it down, or number A you write down. Single angle start connected by single rebate. This is talking about single angle start connected by single rebate or bolt. Okay, that means here what we can say, either there is a single rebate this side, or maybe a single rebate this side, or maybe a bolt part. In this case, what will be the effective length? So effective length, if you are noting down, then note down. Effective length is equal to center to center distance of the intersection of the end connection. That means what we can say, that this simply it is this distance, whatever is this distance is, or what we can simply the length of the angle. Okay, in this case, that means single angle connected by single rebate or bolt, the effective length will be the length of the angle section, or the length from center of the rebate to the center of the other end of the rebate. This is nothing but called the effective length. Next we need to permissible stress. Okay, because once you know the effective length, then you have to calculate the permissible stress. What will be the permissible stress? In this case, as per the code book's guideline, the permissible stress is equal to 0.8 times sigma SC. So what it is saying is that take the effective length, find out the least radius of gyration from the code book, then use this information, get the value of lambda, then find out the permissible stress either using the given equation or the from the table, then multiply it by 0.8. That will give you the permissible stress for a single angle start connected by single rebate or bolt. Okay, next come to the second category. Second category is saying, again it is a single angle start but connected by 2 bolt or rebates or by the weld. Okay, so this is the case. That means it is similar to this, whatever earlier I have done. It is single angle start only connected by 2 bolts or rebates or by the weld. So it is something like that. Okay, so if you provide 2 bolts, so at each end there will be maybe minimum 2 bolt or 2 rebates, or maybe there may be some kind of welding connect will be there. In that case, what is the effective length? Okay, note down if you want. Effective length is equal to 0.85 L. Okay, whatever be the center to center length of this section is, then effective length will be equal to 0.85 times of that length, that is 0.85 L. Okay, and permissible stress is same as sigma SC. That means in this case, if you say the permissible stress is sigma SC dash, then that will be equal to sigma SC. Okay, so this is the case of single angle start. Next we will go to double angle start. Okay, so double angle start, it means what? There is a possibility that 2 angles may be back to back like that. This is how we can say 2 angles may be back to back, or it is possible that 2 angles on the same side of gusset plate. Okay, so how to do on this side? Okay, so code book is given specific by guidelines for each of the cases. Okay, so that is available in code book, code number 5.5.2. So number 1, under that number A, or you can, if you want to write down in continuation of the earlier section, then you write down this is number 3. Write down double angle back to back on both sides of the gusset plate. Double angle back to back on both sides of the gusset plate. This is the case. In such cases, it will be connected by, it will be assumed that it will be connected by at least 2 bolt or 2 rivet, or maybe by the weld. So if you see on the section, longitudinal section, then longitudinal section it will be in this manner. So here at least 2 rivet or 2 bolts or maybe weld. Okay. What about with the type? Whether if you are doing welding, then both side welding. If you are doing riveting, both side riveting. If you are doing bolted connection, then both side bolted connections will be there. In that case, what will be the effective length? Write down. Effective length will be equal to 0.7 to 0.85 times. Okay, so 0.7 to 0.85 times of the L. Okay, and permissible stress will be equal to simply sigma S. Okay, that's it. Start 5, 6. Okay. Next we will go for the next category, that is double angle discontinuous start back to back, connected on one side of a gusset or a section, or by a one or more bolts or rivets in each angle, or by equivalent in welding. Okay, so what it is saying simply in terms of what double angle discontinuous start back to back. So this is a double angle discontinuous start. It is connected back to back. Start 6. Okay. So in this case, what it is saying that double angle discontinuous start back to back, connected on one side of the gusset plate. So if you say this is your gusset plate, so these two angles are connected on one side of the gusset plate. So this is one angle and this is another angle, one side of the gusset plate, back to back. Okay, and then what is said, by one or more bolts or rivets in each angle, or by equivalent in welding, shall be designed as for single angle in accordance with clause number 5.5.1. when it is connected by single angle or single rivet, in that case what we have to do, we have to design it as per the guidelines given in number 1. What is given the guideline? Guideline is saying that the allowable stress will be equal to 0.8 sigma SC, and the effective length is equal to how much? L. Okay, so effective length is equal to L, and sigma SC will be equal to 0.8 into sigma SC. Okay, when we are using 2 rivets or the welding, in that case we have to use the guidelines given in number 2, that is effective length is equal to 0.85 L and permissible stress is equal to sigma SC. Okay, so these are some kind of guidelines given in the code book, and that we need to use for the design of angle start. Okay, so with these guidelines we'll start the problems. In this case, see, we cannot do more problem here in this class, so simply I will take one examples and I will show you in the next slides, means next video. Okay, till then go through this part and check what are the issues and let me know. Okay, take care.